This is Human Impact on the Lithosphere Part 2. And we're going to continue with mining. Last time we largely talked about agriculture, and now we'll be talking mostly about mining and drilling. So, as we've said before, people require certain minerals to live. We need them in our diet so that our bodies function properly. But there are also minerals in the lithosphere that we acquire for other uses. Some are also needs, but others are simply, not necessarily things we need to survive, but things we want, like our cell phones, computers, so on and so forth. Underground mining requires digging out large areas underground, and this increases the risk for sinkholes and cave ins. If you've ever read much about mining, you know right off the bat, as I speak now, that cave ins have always been a concern for miners. Furthermore, strip mining, which is mining where they start at the surface and go down, that also destroys the lithosphere and whatever ecosystem existed there to begin with before the mining started. Now, in most developed nations, mine operators are required to perform a process called reclamation after they're finished mining. And that means they're supposed to put the land back together and restore it to its original condition. Basically, try to make it as much like it was to begin with as they can. Now, is it really possible to put it all back exactly as it was? The truth of that matter is no, they can't. But is it better than doing nothing and just leaving a wasteland behind? Yes, absolutely. All right, let's talk about coal mining. There's two major methods of coal mining. There's surface mining. You basically start at the surface and you just work your way down. And then there's underground mining where you actually, dig a shaft and go down to where the coal deposits are. Coal mining can be harmful to the environment because, first of all, it can disrupt the landscape, and it can increase erosion or cause additional erosion that may not have occurred in that area in the first place. And also, it leaves behind a lot of toxic substances and can pollute air and water. And we'll have some pictures of some landscapes that you'll see in a little bit where mining is taking place, and you can see exactly what we mean by, it being disruptful to that it disrupts the landscape. All right, so here's a picture of some various mining methods, both surface mining and underground. You can see you have surface mining going on the top. They're basically removing the mountaintop and taking these coal deposits out. You have a contour mine. This kind of goes, straight in and gets the coal out that way. You have these, they call them drift mines or high wall or auger mines, which are very similar to this contour mining. Slope mine, you dig a shaft that goes down at an angle and reach the coal deposit and then mine the coal out that way. And then we have the shaft mines, which you dig a shaft directly down to coal deposits. So there's various methods for getting to those coal deposits and acquiring the coal. It just depends on where the coal actually is in relation to the surrounding landscape. All right, uranium and plutonium mining. We use uranium and plutonium in nuclear power plants, and that also must be mined from underground. The three main methods are open pit mining, underground mining, and in situ leaching. Open pit mining is a lot like it sounds. You dig a big pit into the ground and take out what you need, the resource you're looking for. Underground mining, that's all pretty much all the same methods just showed you in the last slide. And then there's in situ leaching, which is a process where you pump water and other chemicals down, and when you bring it back up, you also bring up materials that you were looking to acquire. So, of course, all those methods can create health risks for the workers and also risk contamination of the environment. Also, with uranium and plutonium, we're talking about radioactive materials here. So we're talking about materials that are, they have some inherent danger due to their radioactivity. It can lead to, cancer and other health problems. Here's an example of in situ leaching. So you have the leachate, which is pumped into the ground, and then eventually it's brought back up along with, like I said, whatever materials you're looking to acquire from underground. All right, mining in mountainsides. Mountaintop removal mining. That's like what we saw at the top of our diagram that showed the different mining methods. This is a really destructive form of surface mining where you basically explode the mountaintops, and then pick through the pieces and take what you need, the metals, the coal, whatever minerals you're looking to acquire. It's really similar to strip mining in regards to how it destroys the surface. This is something that's commonly practiced in the Appalachian Mountains. And something we didn't mention earlier, I mean, we kind of did in passing, but we weren't very descriptive. There are these massive transport trucks used in mining, and they burn a lot of fossil fuels and emit a lot of carbon dioxide. And then furthermore, when we burn coal for various reasons, namely in power plants to produce electricity, this also releases a lot of pollutants, carbon dioxide, which contributes to global warming and the associated problems, sulfur, mercury, and then also there is waste ash left over after you burn coal that has to be properly stored and maintained so that it does not get into the environment and pollute soil and water. All right, other human activities in mountainsides. Erosion on mountainsides can be increased by blasting away rock to build roads, such as you see in this picture here. You've had an area of rock that's been totally, carved through, for lack of a better term, and a road built right through it. This is going to increase the likeliness you're going to have erosion here, and rock falls and landslides and other problems associated with such steep slopes. Building houses and other buildings on steep slopes, or just slopes in general, really not a good idea, as oftentimes the soil on slopes can be very weak and loose, like we have talked about in the past, and if the soil comes loose and falls down the slope, the buildings can come along with it. Again, not the first time we've mentioned that clear-cutting trees or removing vegetation from slopes, particularly mountainsides, can increase erosion and contribute to problems such as we've been speaking about already. Now here's some pictures of some mining operations, and this is mainly to give you the idea of just how large scale some of these operations are. You can imagine that this land here, like you have to see this big pit here, but this is once probably a flat area that was dug down into over time. This is just to give you an idea of how massive some of these vehicles are. Many of us drive SUVs similar to this one here. We know we don't get the greatest gas mileage, those of us who drive those kind of trucks. So just imagine what it takes to power one of these, the amount of diesel fuel that goes into one of those, and the amount of emissions, carbon emissions these put out. And yeah, it's pretty massive. Probably would equal many of these trucks. Again, another picture of the size of these trucks. You need a stairwell on the front to get inside of it. Okay, so take a look at this. Down here you can see people. This will give you an idea how large this thing is. This thing works kind of like a saw on the, it's used to dig with, to dig into the sides of mountains with. And this basically works like a series of buckets constantly scooping. So this turns this way, and you put it up against the mountainside, and it just scoops material off the mountainside, puts it on a conveyor belt, brings it back this way to where it's went through and sorted, and the minerals or coal or whatever else that's being acquired is obtained from basically what's stripped off the mountainside with this large saw, for lack of a better word to describe it. All right, let's move on to drilling for oil and natural gas. Oil and natural gas are non-renewable resources, and they're eventually going to run out. I've talked about this in the past. Burning these fossil fuels contributes to global warming, and that's the primary reason we need to shift from using fossil fuels to alternative energy sources. But even if that weren't the case, they're still finite. They're not going to last forever. They're going to run out eventually. Scientists believe somewhere between 50 and 500 years, if we keep going with fossil fuels, we'll use them all up. So oil and natural gas is often found inside of rock or between rock layers. So it's really not all that easy to get to them unless you drill for it and pump the oil out. Oil rigs are used to drill inside the rock and pump the oil and gas out. And this drilling is going to disturb the lithosphere because, like I say, you're drilling right through it, and may contribute to earthquakes. Now, they may not necessarily contribute to large earthquakes such as we experience on fault lines, but they could definitely result in localized seismic activity, along with the possibility of sinkhole damage or other types of lithospheric disturbances. Furthermore, oil spills are a problem from time to time, and oil spills damage ecosystems, kill wildlife. And it's really bad when oil spills onto the ground. It can soak into the ground and become part of groundwater. It can contaminate soil, contaminate our drinking water sources, and also when water. A lot of these rigs, as you see in the picture, they're what they call offshore rigs. They're in the ocean. They go down to the ocean floor and drill into the ocean floor. And when we have oil spills from those, it is absolutely catastrophic. Typically this harms not only the environment but the economy as well, because nearby beaches are polluted and people do not want to go visit these beaches when they're polluted from an oil spill. So there's also, in addition to a very large environmental impact, there can be a significant economic impact resulting from oil spills as well. All right, here's a picture of how oil and natural gas is contained between rock layers. All right, hydraulic fracturing, also known as fracking. All right, this one you've probably heard of before. It's often in the news and a lot of times even in political debates. It's kind of a hot political topic because there are environmental risks involved, namely contamination of soil and water and other lithospheric disturbances. Some people claim that these may lead to earthquakes, and again, I don't believe it would lead to large earthquakes such as we have on our fault lines, but could definitely result in some localized earthquake type effects. So with fracking, we pump pressurized chemicals and water into the ground, and it cracks open rock and enables us to access natural gas, and then we pull all of those chemicals back up along with the natural gas, and then it's all processed and separated. Problems with this include the fact that this produces really hazardous waste, and that waste has to be properly stored and disposed of, and mistakes or accidents in anywhere in the process in the fracking process can lead to contamination of soil and water. And oftentimes they drill right through aquifers, right through water, right through groundwater areas to do this, and they claim that it's safe and that the whole process is contained and that nothing actually touches the aquifer, the water inside of it. But to me, that's very risky. That's not a guarantee. Mistakes can and do happen. All right, so here's an explanation of how fracking works. So gases such as coal seam gas and shale gas are trapped up to 1 kilometer underground and demand innovative extraction processes. Hydraulic fracturing or fracking is one such method. Number 1, drilling. A rig is built and a 22 centimeter wide well or borehole, theoretically watertight, is drilled through rock and sediment layers, some of which are aquifers. Number 2, getting the gas. Fracking involves pumping water and additives down the well at very high pressure. This causes small fractures in the coal seam to widen. Number 3, injecting. The water injected into the fractures is about 90% water, 9.5% sand, and 0.5% chemicals such as acids, salts, gelatin, and enzymes. The additives help alter surface tension between the fluid gas mixture and the coal, helping it flow more freely. The sand helps hold the fractures open. Number 4, extracting. After the water has been injected, it's sucked out again, causing depressurization of the area directly around the well. This causes the fluid gas mixture to flow towards the well, where it's then pumped to the surface where the gas is separated. Number 5, processing. At the surface, the water and gas are separated. The gas is dispatched to a liquid natural gas plant where it is liquefied by cooling, then prepared for export or domestic consumption. Number 6, waste. The wastewater is highly saline, that means very salty, and may contain toxic levels of elements such as arsenic, boron, cadmium, lead, and mercury. It can pose a risk to waterways, domestic wells, and farming if it's not stored and treated properly. And here's an example of a fracking rig. All right, moving on to urbanization, which also has an impact on the lithosphere. Urbanization refers to the growth of cities as more people move from rural areas to urban areas. In social studies, by now you probably have studied the Industrial Revolution and read about or heard about how less people were needed to work on farms because of new advancements in farm machinery, and therefore there had been a mass exodus from rural country areas to urban city areas because the people were looking for new jobs and new work. And urbanization continues to occur today, so it's an ongoing process. Many more people are still moving to city areas from country areas, and just like ever since the beginning of the Industrial Revolution, they're looking for work. So right now, 70% of people in North America live in a city, and it's estimated that by 2025, 5 billion people will live in cities worldwide. So we're at almost 8 billion people on the planet. So think about that. Out of 8 billion, 5 billion are going to live in cities, and only 3 billion in countryside. Destroying natural areas can reduce the beauty of an area and the amount of land available for producing food or for just housing, ecosystems in the environment, which we absolutely need to continue to survive. Rapid development can result in very high levels of erosion and sedimentation in river channels. If you've ever seen a construction site, you've probably noticed there tends to be a lot of loose, sandy, dry soil on the construction site because all the vegetation has been removed for the reshaping of and leveling of the land and the ongoing construction. And that sediment, if not controlled and held in place, can indeed end up in waterways and contaminate the river channels and other water sources. Also, pollution of soils occurs in cities because leaking vehicles and other chemical spills, that stuff ends up on the ground, and then when it rains, it washes into the storm drains and eventually can pollute soil and water sources. Also, urbanization destroys ecosystems. So forests and other nature areas are cleared for cities. You're losing places for species to exist, plant species and animal species. The more factories you have, the more carbon emissions you have, more greenhouse gases we're putting in the atmosphere. And again, this contributes to global warming and the problems associated with global warming. Increased runoff. If you have paved surfaces, you have less water seeping into the ground and becoming part of groundwater and our other water sources and replenishing our aquifers, and instead that water runs off of the paved surfaces, and when it hits non-paved surfaces, increases erosion, and also it's going to carry any of those chemicals that were on the paved surfaces and contribute to soil and groundwater pollution. All right, here's an example of some very quick urbanization. So here we have Shanghai. This is a city in China. And this is a picture of Shanghai in 1990. And we're going to fast forward about 20 years and see a vast difference in this city. So Shanghai 1990. And here's Shanghai in 2010. So you can see some very quick and vast development take place in that 20 years' time. And this is not just exclusive to Shanghai or China. This is something going on all around the world. All right, mitigation efforts, things we can do to try to alleviate or at least reduce the problems associated with urbanization. Installing barriers around construction sites to catch eroded sediment. This is often practice that is utilized, and that's what you see in the picture there. You'll see these barriers. It's kind of like a big barrier made of really robust black fabric. You usually see that around construction sites, and that's what it's for. It's to hold that loose sediment, that sediment that gets loose when they remove the vegetation and move the earth around to make the land suitable for whatever they're building on it. Modernizing landfills to minimize leakage. We'll talk about landfills shortly. We have some problems with landfills where they leak and that pollutes the soil and groundwater. Establishing wildlife refuges and parks. We really need to preserve as much wilderness area as we can, and wildlife refuges and parks are a good way to do that. Upgrading industrial equipment, the equipment in factories, construction equipment, all those things, upgrade them to reduce carbon emissions. That's another thing we can do to mitigate problems associated with urbanization. All right, landfills. So trash that is not recycled is put into landfills. So all the things you throw away that are either non-recyclable or were not separated for recycling, they go to landfills, which is basically a large pit in the ground that's dug, and the trash is put in there and buried. Landfills have liners, which it basically is supposed to seal off all the trash from the soil around it and prevent that garbage from polluting the soil and water. But oftentimes we have a problem where gases inside of the landfill they expand. A lot of trash and a lot of things we throw away, like food that's left over, as it decays, it produces gases, and what this does is it stresses those liners, and sometimes it can break them. It can cause the liners to fail, and then you have whatever hazardous chemicals and whatever else is in the garbage that is going to be hazardous to the soil. It leaks out into the soil and can contaminate groundwater. So we're trying to find ways to modernize these landfills so that this doesn't happen. One of the solutions is that they make landfills that can vent the gases that are produced, and then those gases are actually stored and can be used as a fuel later on. So that's one solution to this problem. But the best solution is for us to produce and use and recycle as many recyclable goods as we can, and try to just reduce the amount of waste that we produce. All right, human activity and shorelines. So North Carolina is well known for its beaches and for the Outer Banks. As more and more people retire, they often move to the coast, and this leads to more development on our coast. And as we develop our coastline, we're oftentimes taking up space that was once wilderness area, and we're taking up space that otherwise housed our plant and animal species. Removal of vegetation at the coast can cause serious erosion. Okay, coasts are already what we would call dynamic, meaning they change over time. They're very susceptible to erosion from the splashing and crashing waves and the ocean currents. And the plants that exist on the coastlines help hold that sand in place. And when we remove it for development, we're causing that erosion to increase and to speed up. Now, there's some things that we build for erosion control. Sometimes we put sandbags out. We also erect structures that are supposed to control erosion, and while they will often control erosion in the area where they're erected, they often make erosion worse downshore. And it's really kind of like putting a band-aid on something that never heals, And we're going to talk about that when we get to our lesson on shorelines later on in the semester. Erosion on shorelines often causes houses to be condemned because some of them, if the sand that they're built on erodes away enough, I mean, the house can end up being, claimed by the ocean, basically. Much like you see in this picture here, you can see this house, you can see the foundation it was built on, and the soil under it just doesn't exist anymore. It's been washed out to sea. So this house is in danger of falling into the ocean. Also, Cape Hatteras Lighthouse, we've had to move it at least once. If I may be wrong about this, but I want to say it might have been moved twice by now. But if we hadn't moved it, it would have fallen into the ocean as well. And this is just due to the dynamic nature of shorelines. They just don't stay the same. They change over time. And like I said, when we develop on the shorelines, this often increases that rate of erosion. Here we have a cartoon. I'm not going to read the whole thing to you. You can read it when you're looking at the PowerPoint on your own. But basically, it's just showing that there's a mindset by a lot of people when they see a wilderness area. All they see is an opportunity to develop it and try to profit off of it, but they're not thinking about the fact that that's not just an empty area. That's an area housing wildlife. Like I was saying, it's housing our plant and animal species. And the more we develop, the more we are taking away space for those species that we actually need to survive. We're taking that space away from them, and we're reducing their likeliness of survival and putting them in danger. I'm trying to remember what this was an example of. I mean, this is the city Rio de Janeiro. I think what they're trying to show you is this is a very developed coastline here. You have a large city right on the coast.